2.7, section 2.7 in your book is about inverse functions. Okay, 5 objectives for us to take care of today. First of all, verify an inverse function, verify inverse functions. Find the inverse of a function. Use the horizontal line test to determine if a function has an inverse. Use the graph of a one-to-one function to graph its inverse. And find the inverse of a function and graph both functions on the same axis. Okay? So some of this we did in Algebra 2. We verified functions, inverse functions. We found inverse functions. We talked about the horizontal line test, but not so much as calling it the horizontal line test. We just talked about knowing if a function has an inverse or not. And we did the last one as well, finding the inverse of a function and graphing both functions on the same one. But let's talk through each one of these to remember. Okay? So first of all, verifying that functions are inverses of each other. I want you to know what the definition of an inverse function is first of all. Okay? So the inverse of a function. If we let f and g be two functions, such that f of g of x equals x for every x in the domain, and g of f of x equal x for every x in the domain of f. So if we do fog and goff, and each time we do it we get x, then that's verification that those two functions are inverses of each other. Okay? So we have f of x and g of x. If we take g of f of x, and we take, f of g of x, and we take g of f of x, and that's true for every domain in each of the functions, those are going to be inverse functions. Okay? Now, we typically use f of x to talk about a function, right? This is the function. We say f negative 1 of x to talk about its inverse. That's the notation that we're going to be using. So if I have a function f of x, and I tell you its domain, what do you automatically know about its inverse? Do you remember? If you know the domain of the function, what do you know for the inverse? You know the range, okay? Because remember how we talked about inverses in Algebra 2? We said that we switch x and y and solve for y. Okay, that's how we find an inverse. This is verifying an inverse, okay? But to find an inverse, we're going to let x and y, we're going to switch x and y and solve for y. So if you know the domain of the function, then you automatically know the range of its inverse, since x and y are both switching, okay? If you know the range of the function, then you automatically know the domain of its inverse, okay? So let's verify that two functions are inverses or not, in fact, okay? So we say f of x equals 3x plus 2, and g of x equals x minus 2 over 3. So to verify their inverses, that we're going to do fog and goff. Okay? F of g of x, we start writing f. Anytime we get to the x, we write g of x. Well, 3 times anything divided by 3, what's happening to those 3's? Those are canceling. Those are simplifying to 1, right? So I get x minus 2 plus 2, which equals x. So I've done f of g of x, and I got x. Is that enough for me to know that that is an inverse? No. What else do I have to do? Yep. I have to do g of f of x. So start writing g, but whenever I get to an x, I'm going to write 3x plus 2. Well, I have 3x plus 2 minus 2, so that's 3x over 3, which equals x. Now have I done enough to verify that these two functions are inverses? Yes. Okay. Any questions about that? Second objective that we need to work on today is finding the inverse of a function. Okay, so to verify inverses, we do fog and Goff. You remember yesterday how I told you I got to teach you how to do it, and tomorrow I'll show you why it's important? Well, that's why it's important, because we use them to verify inverse functions, fog and Goff. Okay, number 2, find the inverse of a function. Well, when we're finding the inverse of a function, that's when we're just given one function and said, find the inverse. Okay, f of x equals 7x minus 5. I need to find the inverse of this function. Well, I'm going to start by making this a little clearer, just in the fact that we typically switch x and y to solve for y, except if there's no y, we can't do anything about it, can we? Okay, so I'm going to switch x and y. When I do that, I get x equals 7y minus 5. Okay, now I just need to solve for y. Well, let's add 5 to both sides. X plus 5 equals 7y. How do I solve for y? Divide by 7. Y equals x plus 5 over 7. Done. Now, if we really want to make sure that we're talking about an inverse function, I want to rewrite this as f negative 1 of x equals x plus 5 over 7. Because the function, the initial function was f of x equals 7x minus 5. This is just in the correct notation for the inverse of the function. Does that make sense?
Is the computer going to ask for that probably?
I do not know that. I do not know. Chances are, typically when they're asking for the inverse, they're going to give you this and just want this. But I needed you to make sure to know what this meant. So, just the notation. Okay? Do we need to do any more of those, or are you okay with finding an inverse? Got it? I'll be happy to. A quadratic? You mean to do one harder than a quadratic? Okay. How about that one? X cubed plus 1. So y equals x cubed plus 1. So x equals y cubed plus 1. So subtract 1 from both sides. X minus 1 equals y cubed. How do I get y by itself? Cube root. Y equals cube root of x minus 1. Kind of. And then go backwards. F negative 1 of x equals the cube root of x plus 1. I mean minus. Pretend that's a minus. Let me do one more. Why do I have to be clear that I'm telling you that x is not equal to 3? Kleenex. Yeah, that would make the denominator equal 0, and then we couldn't have this function at all. Okay? So, let's start by saying y equals x plus 2 over x minus 3. So let's switch x and y. X equals y plus 3 over y Sorry. Y plus 2 over y minus 3. So how am I going to go about this? Multiply by y minus 3. That's a very good start. Y minus 3 here. Y minus 3 here. So on this side of the equation, the y minus 3 simplify, don't they? Okay, so I get x times y minus 3 equals y plus 2. Now, what's our goal again? Isolate the y, right? We got to get the y by itself. So, what do you want to do? Should we go and distribute this? Well, see, I could subtract 2 at this point, except I still have a y over here and a y over here. I got to get those y's together somehow. Okay, so let's start by simplifying, but distributing the x here, and then let's subtract 2. It would not be wrong to do it the other way, though. Okay. If I want to get the y's together, what side of the equation do I want the y's on? Doesn't matter. On the right, okay. So if I want the y's on the right, I need to move the minus xy over here. So I have, can I go ahead and subtract the 2 at the same time? Get rid of that. Minus 3x minus 2 equals y minus xy. I still have 2 y's, right? I only want 1 y. So how can I get only 1 y? I want to actually divide out a y. Yeah, there's a y here and a y here. It's a common factor in both of those terms, so let's divide out a y from each one of those terms. What do I have left when I divide out the y? 1 minus x, right? Dividing a y by a y gives me 1. Dividing that by a y, I get an x. So negative 3x minus 2 equals that. Well, now I only have one thing left to do, and that's divide both sides by 1 minus x. Because on this side, the 1 minus x simplifies to 1 now. And I have negative 3x minus 2 over 1 minus x equals y. How would you simplify it? I'll tell you this, it's not the answer that's in the book. You want me to tell you what the answer in the book is? But what did I do? I multiplied the top and the bottom both by negative 1, which is multiplying by 1, so I haven't changed the value of the problem. Okay? If you put this in and it says something else, like it's in the right form but not quite the right answer, try multiplying numerator and denominator by negative 1. This should be correct though because it's right. Okay? And then of course we want to write it in the correct form. F negative 1 of x equals 3x plus 2 over x minus 1. Do we have to worry about the domain here? Remember the domain was not 3 in the beginning? Is it okay if it's 3 right here? Yeah, so we're good. Okay, now we don't want this to be a positive one, do we? But we're good. How do you feel about finding inverses of a function? Okay, using the horizontal line test to determine if a function has an inverse. Okay, now here's what I want you to remember from Algebra 2. We said we did a lot of graphing of functions and their inverses, and we realized pretty quickly that since we're taking x and y and switching them, if I graphed one and then its inverse, what line are these things reflecting across? Y equals x. Okay, they're reflecting across the line y equals x because I'm actually making x and y like switch places. Okay, so typically if we are trying to determine whether something's a function or not, we use the vertical line test, right? Well, if we're given the function and asked if this function if this is a function, we still use the vertical line test, right? But we might be asked, is its inverse a function? Well, would it make sense then for me to do the horizontal line test to see if its inverse is a function? Okay, so tell me right now, is A a function? Yes, it's a function. It only touches the vertical line one time. Is its inverse a function? Yeah. Is this a function? It is a function, only touches it one time. Is its inverse a function? No. What about C? Is it a function? Yes. Is its inverse a function? No. This one? Yes, it's a function. What about its inverse? Yes. Okay. And then if you read this part where it says solution, it says A and D both represent functions that have inverses. Okay? So what about this one? Oh, that's the answer. Sorry, that's the solution. What about these three right here? Is this a function? Yes. Is its inverse a function? No. Is this a function? Is its inverse a function? Okay. Is this a function? Is its inverse a function? Yes. Okay. Right underneath that is this bold part right here that I need to read to you. You know I don't like to read to you, but this is important. Okay? A function passes the horizontal line test when no two different order pairs have the same second component. So it passes the horizontal line test. Okay? This means that x sub 1 does not equal x sub 2, then f x sub 1 does not equal f of x sub 2. Such a function is called a one-to-one function. So a one-to-one function is a function in which no different ordered pairs have the same second component. Only one-to-one functions have inverse functions. So this one right here, is it a one-to-one function? Well, it is a function. Is its inverse a function? No, so it is not a one-to-one function. Is this one a one-to-one function? It is a function and its inverse is a function, so it is a one-to-one function. Do you understand that? Okay. So that's using the horizontal line test to determine if a graph has a function or not. Okay. Number 4 of our objectives says use the graph of a one-to-one function to graph its inverse function. Well, here is... Okay, that's the origin. I don't know why I was marking that for you. You guys know what that is. Weirdo. I'll do something weird. You guys have inspired me today. I'll do one more right there. So is that a function? Yes, right? That's a function. So I need you to graph that function, that inverse on the same coordinate plane. I want you to graph the inverse of this on the same coordinate plane. Well, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 8, 3 is the first point. So what point is involved in the inverse? 3, 8. I switch x and y, right? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6. Negative 6. Oh, that's negative 8. Ignore that part. It's okay. Negative 8, 3. So I got to do 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. It happens to the best of us. It's fine. Okay. We figured it out, right? That's the most important part. So if this point is negative 6, 0, negative 6, 0, then we got to graph 0, negative 6. 4, 5, 6. This one is 1, 2, 3, 1, 2, negative 3, 2. So I got to do 2, negative 3. This one is 1, 2, 3, 4, 5, 6. That is 0, 6. So I've got to graph 6, 0. 1, 2, 3, 4, 5, 6. And then this one is 1, 3. So 1, 2, 3, 1. So here's the thing. If I folded this piece of graph paper along the line y equals x, is it a mirror reflection of itself? Then it's an inverse function. This is the correct inverse of that. Does that make sense? Okay. Do I need to do any more examples of that for you, or you got how to graph an inverse function? Okay. Now find the inverse of a function and graph both functions on the same axis. So what I need you to be able to do is all this stuff. Find the inverse function and know how to graph this one on the same axis. So this would, on the same coordinate plane. Okay, 1 over 7 plus 5 over 7. That's what that really means, right? 1 over 7, like that. Can you graph that on the same coordinate plane as you can graph that? Yeah, that's the y-intercept, that's the slope, right? Okay. Now it's going to be kind of messy with 5/7, but is it still going to, you think, cross at x equals y? Okay. You know how to graph a cube function? Well, this is just a cube function that has a transformation up 1, right? Well, this is just a cube root function that has a transformation right 1. Isn't that going to reflect across the line y equals x? Okay, so do you have any questions on being able to find an inverse and graph both functions on the same axes? That's what it means, coordinate plane. I kept saying axis, which is why it was confusing. Okay. Any questions about any of this?